Hello, everyone. Welcome officially to our webinar today. We Blues are super excited to welcome our friends from Useful Sensors to our presentation. And today we're going to really focus our time on what many of us consider to be critical for the future of the IoT, and that is AI, or more specifically, machine learning, and an even more narrow definition of ML as it pertains to generating inferences on really constrained devices, that being TinyML. And every time I personally talk about machine learning, I think back to a few years ago when I first started dabbling with TensorFlow Lite. That is the framework that's really the underpinning, if most, if not all, TinyML services today. And I quickly learned machine learning wasn't really the kind of the binary or black and white process that I had come to expect as a developer of many years of writing code. It's very imperfect at times, but also incredibly powerful and useful, as we are seeing play out. We're seeing this play out on a macro level on a daily basis. And as this all relates to the IoT, I really love this quote from Stacy on IoT, where she expresses that the IoT really needs TinyML, right? There's so much data out there that needs gathering, needs processing, interpretation. And I think this relationship between consuming that data, generating those on-device inferences, focusing on privacy and security, and then relaying that data to the cloud is really critical and a powerful story. Now, before we really get started, if you have any questions during the presentation, please go ahead and ask those in the Q&A panel or the chat panel provided. Either one is totally fine. Ask them as they pop into your head. We do want this to be more of a casual conversation today, so feel free to ask away. We'll do our best to answer all your questions as they come up, but we'll also probably try and hopefully have some time at the end to do more lengthy, more public Q&A. Now, one question I do want to head off at the pass is this being recorded? The answer is yes, it is being recorded. It will be available on the Blues YouTube channel at this URL. While you're there, of course, I recommend subscribing so you're the first to see any and all new video content that we provide. Now, let's talk about what we're going to cover today. So based on the registrations, I know a sizable contingent of you are new to Blues and how we approach wireless connectivity. So I'm going to do a really quick overview of what Blues is all about. I'm then going to turn things over to Pete and Terry from Useful Sensors so they can dive into what their company is all about, the products they provide. But we're also going to tie everything together and show off a project that Blues and Useful Sensors collaborated on for the Blues booth at CES this year, which was just earlier this month. So quick introductions. So my name is Rob Lauer. I'm Senior Director of Developer Relations at Blues. More importantly, with me today is the aforementioned Pete Warden and Terry Mershot from Useful Sensors. Also here is TJ Van Tol, who's our Principal Developer Advocate at Blues. Super happy to have you all here today. And let me kick things off. So again, I need you experienced Blues veterans to hold on for just a few minutes as I introduce the rest of you to Blues. If I may be so bold, I would say our mission at Blues is to simplify wireless connectivity, full stop. How do we make that happen? Well, our focus is really on securing your data. You could say from the moment it's acquired by a sensor all the way through to landing on your cloud application of choice. All of our hardware solutions that we will show off today are low power out of the box as well, as low as 8 microamps. That's microamps when idle for the cellular note card. We're also very much a developer-focused company. Our dev experience is really a top priority, and you'll see that kind of play out in our hardware and our APIs as well. And also, all of our hardware is swappable in terms of the physical connectors, but also with the developer APIs. So effectively with Blues, you can have different radio access technologies in the field using cellular, using Wi-Fi, using LoRaWAN, but all using the same firmware code base. Now, the core hardware product we provide is called the note card. And we have a few different options here, 4 different options. We start here with a cellular-only note cards. So this is a great option if you only need Cat1, LTE-M, or NB-IoT-based cellular. The note cards do come prepaid with 500 megabytes of data, 10 years of global service, no monthly SIM fees or anything like that. There is also a Wi-Fi only note card that's based on the ESP32S3. It's a much cheaper version of the note card. There's also a new LoRaWAN only note card for connecting to the Things Network LoRaWAN gateways, also very, very inexpensive. That's coming out almost exactly a month from now. And a new set of dual cellular and Wi-Fi note cards were just released at the end of last year that allow for using either cellular or Wi-Fi But more importantly, this really awesome feature of Wi-Fi to cellular fallback. So if your device gets out of range of Wi-Fi, it'll automatically switch over to cellular. Again, note that they all use the same physical M2, M.2 connector and share the same development APIs, more or less, depending on, of course, individual functionalities on the note cards. I do want to zoom into the note card just a little bit more. Again, it is a low power system on module. It's very tiny, measures at 30 by 35 millimeters or 30 by 42 millimeters for the cell plus Wi-Fi note card. Again, they all have that same M.2 edge connector. And again, as mentioned, there's cellular Wi-Fi LoRa variants. The cellular one does include a GPS module as well. Again, cellular note cards come prepaid, 500 megabytes of data, 10 years of global service, no SIM fees. You can top them up with more data as needed. Meant to be a very easy to use cellular device. The note card does have an onboard embedded SIM, but if needed, you can add an external SIM, and we provide dual SIM support so you can actually programmatically switch between them if needed. Now, the API, the way you interact with the note card, is all JSON based. So it's very easy to use. You're not issuing archaic AT commands to manage your cellular radio. But to make it even easier to use that easy API, we offer a bunch of supported SDKs for popular languages that many of us are already using, which is awesome. And finally, there are a whole series of carrier boards that we call note carriers. These are for like prototyping or even with deploying in the field. This one, for example, comes in our starter kit. It's called the Note Carrier F. It's got a very convenient slot for slotting in a feather-based host as well, and the note card as well. So super easy to get started with that. Now, I do want to be clear that when you're investing in Blues in the note card, it's actually not just the note card. Blues provides this end-to-end, especially on the cellular side, literally off the public internet communication channel from the note card through to our cloud service Note Hub to your cloud of choice. You can even optionally encrypt data as well. And again, you can deploy with cellular, with Wi-Fi, and or LoRa, and you're not jumping through a lot of hoops to get there. It's a super simple but very powerful workflow. But if you're like, oh, hold up, not another cloud service, I do hear you, but this is actually the beauty of Blues. Because in the traditional model of adding wireless capabilities, you're doing what? You're sourcing a modem, you're sourcing a SIM, you're paying a monthly fee for that SIM, you're spinning a custom PCB, you're managing battery life, you're writing AT syntax to manage that cellular radio. You're also managing tower handoffs, rotating keys, all that kind of crazy stuff, right? And you're writing some cloud function probably, all to get your data from your device to your cloud. It's kind of a wild ride. Instead, you can think of Blues as providing that infrastructure, like Visa or MasterCard are in the credit card world, right? Because Blues provides the infrastructure for the wireless IoT. We build that secure private infrastructure that provides turnkey bidirectional syncing of data between your cloud and your device. We're not dictating the clouds you use. We're not dictating the microcontrollers or the programming languages you use. We're also providing that low power management, tower handoff, cloud integrations, no monthly SIM fees, all that kind of good stuff. And the reason I bring this up is because everything I just described about Blues is actually related directly to why we love working with our friends at Useful Sensors, because I would say that we are both working to solve these really hard problems and making developers' lives easier. And historically at Blues, we have been really invested in a variety of ML use cases, but we've seen how valuable they can be for people. I highly recommend those of you who are curious, check out our page on Hackster so you can see all of the TinyML-based project tutorials we've already created. Some using Edge Impulse, some using TensorFlow Lite directly, and at least one of my favorites in particular that uses this beautiful piece of hardware from Useful Sensors called the Person Sensor. In this project, I actually wrote this almost a year ago. I literally wrote a cloud-connected person sensor in 30 lines of code, no joke. Pretty simple in function, yes, but really powerful behind the scenes. Because using the person sensor and Blues, I was able to generate private on-device inferences of counts of faces detected along with some additional metadata. But then using the cellular note card, I was able to relay this data to my cloud. Again, that could be AWS, Azure, DataCake, UbiDots, it doesn't matter. And here's the full Arduino sketch I wrote. You're not meant to be able to read it here necessarily, but I think I just want to get the point across that we as developers really can and should be embracing these lower code solutions. You don't have to give up full control that you're used to as long as that right developer experience is provided, which I think both of us do really well. If you want to see this particular project on Hackster, you can use this bit.ly address to get you right there. Now, that's enough of me blabbering on. What I'd love to do is invite Pete to the stage. So Pete is CEO of Useful Sensors and considered one of the founding fathers of TinyML. So Pete, I will stop sharing if you want to go ahead.
Awesome. I don't have slides, but I do just want to talk through and what what we encountered. I've been a fan of Blues for a long time because of that really straightforward developer experience. I've looked at wireless solutions in the past for accessing cell data in particular, and it's been really daunting. I'm not coming from that world, and it really did not make you know, much sense in terms of the amounts of complexity that I would actually have to deal with. But the really nice thing was I was actually on the hook for writing this demonstration for CES. And I don't spend much of my time writing code these days. As CEO, I have a million random, much more boring things I have to deal with. I was able to, with the help of Blue's starter documentation and the starter hardware kit that I got, I was able to very quickly get up and running with the person sensor. It really blew me away, both how straightforward the connectivity and the ability to send a JSON object to the cloud from an embedded device, how straightforward that was, but also how good the Blues documentation around the process was. And, I think I've emailed privately saying how impressed I was with the really clear step-by-step guides with screenshots of exactly what all of the sort of options and things that you're looking at should actually be. Um, I've emailed that privately, but I just wanted to give a shout out to Blues and, to the people on the call. If you're thinking about, dipping your toes in the water, I like to say it's so simple, even a CEO could do it. So just a shout out to that. And I actually wanted to give Terry, our CRO, a chance to talk a bit more about what we're doing at Useful. And then, I'm happy to, maybe come back and talk a bit more about the technical things that I encountered while I was building this.
Thanks, Pete. Yeah, at Useful Sensors, our goal, our mission is to make interfacing with everyday electronics and appliances as easy as communicating with another human. And whether that's through presence detection or gesture recognition, glance detection, we even have natural language models, voice input and control, things of that nature. TJ's holding up a very small one of our person sensors right now. It's really tiny, and that's basically the goal of the company. And we do it in a way that is really, really low power, low cost, small size, and very, very secure. For example, the person sensor is a module that we sell that's under $10 in high volume. It can get much lower than that, and no personal data comes off of that module. You cannot get an image of someone off of that module. It's just metadata. So very, very safe, very private, very secure. And as Pete had mentioned, working with the Blues team has been phenomenal. We participated at CES in their booth. We populated a few of these people sensor modules in and around the booth and around CES. and we were able to pull some very meaningful metrics in terms of um, population density. So basically, people standing in front of a booth, looking at a given display, for example, how long they're paying attention to that display, right? And I think, TJ, did you show an example of that combined hardware of that
Yep.
module that we put together? There it
Yeah, so
is.
we had three or four we had four of these situated at different places throughout CES with a person sensor hanging out the front of this. And then I'll show in a minute, I'll break this down and I can show the insides of this with no card inside. But basically this is what was pointing around. So you'd come look at a booth or a display, and then I'll get the light if I'm fast enough to see the LED to recognize that I'm looking, and then it's just paying attention to what I'm looking at, what I'm paying attention to, which was super nice just to get some analytics around who was at the booth. We had one at the front of the show too, which was pretty fun. That one got a lot of activity.
Yeah, thank you. And so basically, as you saw with TJ holding that unit up, I mean that's the size and form factor of something that obviously is quickly deployable, something that can be developed rapidly. Obviously, in a more commercial application, that can be scaled down in size dramatically. But yeah, a lot of useful data in terms of um, who is spending time looking at certain areas and participating and engaging with certain portions of the booth. Was a decent sized booth, and also population density and traffic coming through different parts of CES. So anyway, um, Rob, if you want to throw up on the screen some of the examples of what you can do with some of this technology, I'll walk through that real quick and then turn it back over to Pete.
Yeah, absolutely. Let me see. Now you're making me go through this process again where I can't find my screen. Here it is. So let me bring them all up and then we can just discuss them all.
There we go. Perfect. So just some examples of what you can do with this technology, right? We talked about traffic flow patterns. You can be a retailer and you can have these things in a store, and you can actually utilize this to take a look at what these flow patterns look like. Are people spending more time in a given aisle? Are they spending more time in a given section in that aisle? Are they physically looking at a certain set of products in that aisle? That's really, really important for retailers to maximize ROI, and placement is critical. Same thing with vending machines. You want to be able to have a vending machine and place it in a certain area and know that that's a popular area, and not just that a lot of people are walking by, but that people are also, looking at the device, interacting with the device, taking product from the device. Um, and the same can be said for some of these other applications and use cases here, right? We go all the way to the end, and basically this is what we did at CES. It's attention span capture. How many people are engaging with a booth and not just walking by? How many people are engaging compared to how many people are walking by? How long are people spending at a certain portion of that booth, right? Um, and many, many others, right? So with that, I'll go ahead and turn it over to Pete.
Awesome. And I figured I would actually uh, just walk through the coding process a little bit, just to try and give people an overview of what I ended up needing to do. And let me just share my screen and share Chrome here. So the documentation that I found super useful was this quick start guide. And it's actually a collection of 4 different stages that you'll go through. The first one being just setting up the actual card itself. And this might look a little intimidating because it seems quite long. But the nice thing is that it's actually long because it's really taking you step by step through everything you need to do. And once you have the hardware and you just get things plugged in, it really, I was able to go through this pretty quickly. One of the concepts that I sort of had to wrap my head around a bit, and Rob and TJ can kind of give their own implementation or their own interpretation of how this works. But a key concept for me was the idea of a note hub, this sort of layer of indirection where all the data you send goes to Blue's almost like data router as a first step. And so what that means, one of the nice things that means is you can get your implementation working very quickly and start seeing data actually showing up on that website very quickly. And I will actually just give you a preview. So I'm just working around all the Zoom windows here. Whoops. Here we go. To actually show you the project, the Note Hub for this project that I set up. And I believe you can see this is actually TJ's was doing some data testing. So you can see there's a bunch of Michigan locations where this data is being sent. And the important thing to notice here is this data packet. So this is the core idea of a lot of the the whole way Blues works is you have JSON data packets that you send from the device. And jumping back to how this actually works in practice with the person sensor, this is very similar to Rob's example that he showed on GitHub, on the Hackster, where it's reading the person sensor and then sending data up to the Note Hub cloud. And just kind of walking through this, this is an Arduino sketch. So you start off by including an Arduino library. You then include the note card library, which has all of the functions you need to actually communicate up to the cloud over the cell network. You define a unique ID. And by the way, I'll just throw this in the chat too in case people want to follow along. And one of the things we have to think about is, okay, how often do we want to send data? So we have this transmit delay idea expressed in milliseconds, where we basically send every 15 seconds. Now, one thing about the person sensor is we started off by looking at the person sensor every 15 seconds as well, because that's when we were transmitting data. But as we were working on the application, we realized actually trying to get a weighted average of how many people were present over the course of that every 15 second sort of chunk of time was actually more useful for the kind of retail analytics application that we were looking at. So we actually ended up deciding to sample the person sensor twice a second and then take those 30 observations of how many people were there and how many people were looking at the device and average them So one thing you'll see later as I walk you through this stuff is you'll actually see some fractional values for how many people were actually present, which can be confusing, but it's not like we had half a person. It's just that out of that 15-second time, maybe somebody was only there for 7 or 8 seconds. So the setup was pretty straightforward. Just you start up the note card object that you've defined as a global up here. You tell it what the product is, and one interesting thing that we can come back to is sort of the mode that we want to run in. This is important because running in continuous mode basically keeps the modem running all the time, so that it's ready to actually send stuff immediately without having to kind of like delay and wake up the modem. And if you're sending things every 15 seconds, it's not worth setting it into any other mode. Now, for something like a trail cam, like we talked about, it might be that you only want to send data, once an hour or something much less frequent, and you can use a different mode to avoid having the power draw of that modem being on continuously. And once we've done all of the setup, we then go into this loop function, which runs actually twice a second, because that's how often we're sampling the person sensor. So we keep some running totals for the statistics so that when we actually get to read or to transmit the data, we can transmit that sort of running average that I talked about. From our side, from the useful sensor side, we provide a person sensor.h header file for Arduino. We actually have found that to be a little simpler even than installing a library. And it's just a very, it's a pretty small sort of basically driver that lets you read or write to the person sensor over I²C. So going back to the code here, we actually try and read from the person sensor. If we can't find anything, then we display an error on the serial. But otherwise, we actually look at how many faces were spotted by the person sensor in this sample. And then we go through and we look at how many faces were actually facing the sensor, because especially at somewhere like CES, we really wanted to know the difference between, okay, is somebody like walking past our poster or our TV, or are they actually stopped and looking at, what's going on? Because that gives us a much richer idea of whether people are actually paying attention to what's happening. And so we're running this, twice a second. If we get to the point where it's been 15 seconds since we last transmitted, then we dive into the note card transmission code. And we do some setup here just to sort of tell it, tell Blues exactly where we want this data to go. And then we just add 2 numbers to the body of this message, how many faces were spotted, and then how many of those faces were actually looking directly towards the device. And then we send the request. And from a user point of view, the next thing that happens to that data is it shows up here on the Note Hub. And this was
Pete, if you refresh it real quick too, I'm trying to look at this now so we can get some data with some actual faces in there.
oh, awesome. Yeah,
At
that
least we
will
should.
help.
Yeah, there we go.
Oh, perfect. Yeah. So what you can see here is this is actually fresh data that's TJ has just added on. And if I this is not a public link, so I won't share the URL because you wouldn't be able to view it. But what you can see here is that there's varying numbers of faces that have been spotted over time as TJ has been sort of, experimenting with holding the devices in front of him. And you can see that there's different numbers of facing faces, and like you can see here, sometimes there's 0.47 faces over that 15-second time period, but only, sort of 37% of them were actually facing the device. And the nice thing about this is you can actually make sure that one part of your system is working fully before you have to worry about all of the other things that go into turning this from just essentially a log file full of all of this data into something that you can actually visualize. So it was a really nice separation of the development process, being able to get these things into the Note Hub and actually make sure that the data was making it through and get that all nailed down before I had to worry about, okay, now I want to visualize this. How do we, how do we set this up? I'll go to the routes tab. And again, this is all covered in the starter guide. So this is stuff that I, learned from the documentation. You go to the Google Cloud configuration, because in this case, I wanted to build our visualization on Google Cloud. You give it a URL to send the data to. In my case, I didn't set this up as an it didn't require authorization. And what happens then is when events are received by the Note Hub, it actually sends the JSON packet that you specify to that URL that you've just put here. And one of the nice things is you actually get the chance to do some cleanup of the data packet as well and just send exactly what you need by using JSONata, which is a way of expressing how to turn one JSON object into another. And you can see here, we take the num faces and the num facing faces, but we also actually make a note of the location just for debugging purposes. The device ID, so that we know which device is actually running here, and also the time that this stuff was sent. And to understand how that's used, I'll actually go over to a lot of this involved me setting up a Google Cloud function that's running at this URL, which took this data and stored it in Firestore, so Google's database product. I won't cover the code that went into that. It, ended up being a few lines of Python. And there's there's some good tutorials available for that. But where it gets interesting is once you actually go to the web front end where we're actually going to view this, and if I look at the Python code here that I'm using to write this front end, I'm using a graph library called Streamlit, which makes it really easy to put together updatable charts through Python running in a front end. I have a function that's called every time the database changes. And what I end up doing here is this could be done more efficiently in the database itself, but I basically say, give me everything in the database. So every single event since time began in my Python code. And then I'm going to go through and organize it so that they're in an array, in a dictionary where they're organized by each device having its own list of events. I then sort each list of events by time. So the most recent ones are at the start of the list. I then say, hey, only give me events from the last hour. And then once we've done that, actually go through and create something that's going to be simple to put into a pandas data frame with this PD data frame setup here. And then I make sure that we have that function run every time that the data is actually changed. And then I use a bunch of charting stuff from the Streamlit library to actually visualize what's happening here. And if I go into the server folder for this, and I'm going to be if I run this app, then fingers crossed, give it a second, and it should actually be able to pull down the data and actually show you the number of people over time and the number of people who are actually looking at the device. And you can see from the time values here, I think TJ has a couple of these devices. One of them was stuck on the fridge at the CES, so it's labeled as Blue's fridge. One of them was on the billboard at the front of the show. And you can see over the time that we've been talking, he's kind of been pointing it at himself, and you can see the sort of data coming in over time. And it was, it was a plumbing job to get this up and running, but I really did not encounter anything that was that made me have to think hard to actually get this going. So, if you're at all interested in this stuff, obviously I like using person sensor. I found, I believe most people have found that fairly straightforward to get started with, and then getting the connectivity through Blues was very very straightforward. So yeah, I figure that's a good place to pause and see if TJ or Rob want to jump in.
Yeah, that's
Yeah.
great. Have we shown the person sensor itself off well
We
enough?
should, I was just going to give people a hardware tour here real quick. So I got a person
Yeah.
sensor here. I'll show what's actually, I'm just going to switch over my cameras here because yeah, I've got the person sensor over here if I can get it to focus on it because it's a pretty, oh yeah, Rob pinned me. That's good. So I've got the full devices we had on CES over here, but I think it's actually more interesting if we sort of break these down. So I'll take the full build out of the way, and I have one that I gutted over here so you can see the individual components. So what you're looking at in the middle is the note card. This is a cell and Wi-Fi note card. We've only got it using cellular at the moment. So I could give this a Wi-Fi network and the note card would use Wi-Fi by default and fall back to cellular. But at an event like CES, if you've ever been at some of these big conference shows, you don't want to rely on the Wi-Fi at all. It's pretty much unusable anyways. So we just use cellular and it worked fine even in that venue. The board that this is in is a development board we called a note carrier. You might have saw in Rob's slides earlier. And these are dev boards that their job is really to give you an easy way to house the note card, but then also have some developer conveniences like these JST connectors up here. These connectors on the side for USB and Quick. So at the actual event, these JST connectors, one of these is for batteries. So each of these have a LiPo battery in them to provide for power. If you're running in a situation where you have access to mains power, you can just power this thing via USB as well. So that's another option you have. There's also the pins are exposed here. These pins on the side are for a feather compatible microcontroller. And we call this the note carrier F, with the F being for feather. The idea being you can take a microcontroller like this one we make at Blues called the Blue Swan and quite literally just slot it in there, assuming I can line up the holes correctly. And that provides all the connections necessary so the microcontroller can talk to the note card. And all of what you see here, this section is what we sell at Blues in a Blues starter kit. So Blues starter kit comes with a cell plus Wi-Fi note card. It comes with a note carrier F, and it comes with a Blue Swan microcontroller. And Rob, maybe you could drop a link to the starter kit in the chat so people know how to get this piece of the puzzle. And then when the person sensor comes into it, this is actually really, really simple as well. So I have the person sensor. You'll see it has a quick connector on it. And I have a quick cable, which is a simple little cable. These are like dollar cables. They only go in one way. So I'm going to do this off camera so I don't embarrass myself here for a second. And this quick cable, we also have quick connectors on both the note carrier F and the Swan. So it is quite literally as easy as just inserting things. And at this point, if I take in, I'll just plug in the battery too, so you can see this thing. It'll actually just start working and reporting data because this is actually all there is to it. This is a fully functional setup. It's just a Blue starter kit, a person sensor, a quick cable, and a LiPo battery. That's all there is to it. It's great because if you're someone who's not an electronics expert, there's no soldering involved. It feels like putting together a Lego set, honestly. It's somewhat satisfying, actually. And then the only thing we added, the only thing that's custom on top of this for what we did at CES is we did have 3D print an enclosure for this. So that's one thing that we added that's custom. If you are curious in building this exact setup, we can share the files for that enclosure with you. We're working on putting that up someplace public so people have access to it. But in the meantime, if you're quite literally looking to replicate exactly what we did, we can help you out with the files to generate that enclosure. But I love it because it's really quite simple. I think it's the ultimate sort of prototype demo type of thing because it's pretty easy to get this hardware. It's very easy to slot it all together. You can be building, you can be prototyping. And then really all Pete did was that firmware that he was showing just goes on the Blue Swan. So basically you connect either through USB or an ST link through this debug port over here. You push your firmware to it and you're basically off to the races at that point.
That's awesome. There's a bunch of questions that have come in. I think I wouldn't mind. I know we're getting kind of close to the end here. I can start kind of like asking some of these and I'll remove TJ's spotlight. One that's timely, somebody's asking if how many person sensors you could connect to one note card or one note carrier. I'm assuming, is there a way to change the I2C address on the?
There
no?
is not at the moment. Yeah, we decided against going for the dip switch on that. So unfortunately, you can only connect one person sensor at a time. That's if somebody has a use case where they're actually looking at doing that, we're happy to chat and figure out how to work around that for you.
Sure. I'm gonna kind of popcorn around here with other questions because there's some in the Q&A and some in chat. I guess the next one here, somebody's asking if there's a Raspberry Pi starter kit for Blues. There's not a specific starter kit, but we do offer a Note Carrier Pi hat, and you just need that along with any one of the note cards to work with the Raspberry Pi.
I've got the hat. There was also a question. Somebody asked if Useful Sensors has a Python library as well. I don't know if you guys have that available for the person sensor.
We do have both a Python library for the Raspberry Pi and MicroPython and CircuitPython implementations.
Excellent, because we do at Blues also. So the firmware you saw Pete running, you could just do that in Python or CircuitPython, and we have support on Blues and Useful Sensors. So if that's more your flavor, and you can run a CircuitPython on the Swan as well. So you could actually either with a Pi or with the same hardware we showed, do it in Python if that's your thing.
And it looks like Evgeny has an interesting follow-up. He's using an I2C Mux to connect multiple sensors. I haven't actually tried that myself, but that's one of the things I was thinking of is, using an extra piece of hardware to be able to, flip between different sensors.
Makes sense. Here's a high-level question for Pete or Terry. What other sensors do you offer with TinyML? What's planned for the future?
Terry, do you want to?
Yeah, so we have a texture sensor that is really, really low cost, geared towards sensing carpet and tile and things of that nature with some machine learning algorithms on there. Super low cost, super low power, does a really good job. The person sensing, we're actually coming up with new algorithms to enhance or expand that. Right now, the person sensor does its detection by doing face detection. So we're looking at doing whole body detection for applications like security lights and things of that nature. We also have like I said, a voice input command control. Think of it as a chat GPT like interface, but completely disconnected from the internet. It does language translation, I think, in 15 different languages in real time, transcription, very, very powerful hardware for that. But we're open to ideas as well. I mean, if you've got a use case that's interesting, contact us through the website, and would be happy to chat about that.
I've always had this. As soon as I saw that product announced, I was like, the perfect application for this is when I'm visiting my doctor. The doctor spends the entire time at the keyboard typing stuff, and I'm like, if there's just something that could like record these notes and condense them like magically, like we get those Zoom summaries, and granted, they're not always perfectly accurate, which maybe is not ideal for a healthcare setting, but anyway, that's my product idea. You're free to take that.
He's looking for early investors.
Yep. Let me see here. I had another question and I just lost it.
I do like this one that just came in. Are there lighting requirements for facial recognition?
So
yeah, jump in. No, you go ahead.
I would say that, our person sensor right now, please keep in mind that the way machine learning works is that you're basically optimizing for a certain use case. So different use cases can be optimized for what it is specific to that use case, which would mean, working on retraining that algorithm for that specific use case, which is something that we would do for a large engagement with a large company. But as is out of the box, it works pretty well in low light conditions. I don't think we have a specific spec, a Lux spec in terms of what that looks like, but it's an imager that also is capable of receiving IR as well. There's no IR cut filter on that imager. So if you had an application where you had low light or no light, you could add a very low cost infrared LED to your setup, and you would be able to image even in a no light condition.
Two kind of similar questions came through. Well, not that similar, but somewhat related. Can the useful sensor model be trained to recognize particular people? And somebody asked if it could be trained to recognize like objects, or I know the answer is no for the person sensor, but yeah, any plans, I guess, along those lines?
Yeah, I mean it depends on the use case and the engagement model. We're not a company that is a bespoke engineering solutions company in terms of being, engineers for hire. However, if there is a use case that you guys have interested in, just contact us through the website. It might be something that we're already working on. Or if you've got a large engagement, decently large engagement, contact us and we might be able to do something for you. But basically, the model right now is face detection. We're doing a model that's just more of a person detection. It can tell the difference. It's not taking a picture of your face and basically saying, oh, I've got a picture of Terry or Pete or whatever. It's pulling metadata. So there is some limited features in terms of discriminating between various members of the family, for example. Like if you had 5 people in a room, can it tell the difference between person A and person B? Yeah, there's some limited functionality there. And like I said, if you like more information, just contact us through the website and we can hook you up.
A couple of people, yeah, a couple of people asked this question: does the person sensor work as a camera as well? But you just answered that it's not actually taking pictures.
Yeah, it does not.
I'm going to do one rapid fire
Yeah.
one. Somebody asked about tracking with the note card, and the answer is yes. So there's a GPS module on the cellular note card, and then the Wi-Fi note cards also can do Wi-Fi triangulation for location as well. So you have some different options depending on the note card you get. But yes, tracking is definitely a thing you can do.
And I think you know the answer to this one as well. The models that are on the sensors are fixed; they're not user updatable. Correct?
That's correct.
Yeah. There were a couple of this one in the examples shown today, Arduino was used. How does the Arduino board connect to the note card note carrier like the Swan board, and which Arduino board is compatible? I can't speak to which Arduino boards specifically are compatible, although I think any modern one, even including the Uno, is compatible. So I mean, the one thing we kind of pride ourselves is that any modern host will work with the note card and note carrier. And
yeah, the
note
way it
carrier-
works today is basically our note carrier does all the wiring for you, but you can just talk to the note card over serial, over UART, and send messages. So we're showing kind of the happy path, but if you have a specific host in mind, a specific way of doing it, you can do that with a note card. It's just a little more grunt work to make it happen.
Yeah, there are a couple other questions here I want to address. One has to do with the person sensor, the other with the AI in a box. So the person sensor, the resolution is 320 by 240. It's a low res camera. The field of view is plus minus 30 degrees, I believe. The detection distance is, I think on that one. So Pete, did we use the person sensor or the QR code reader for that application?
Sorry, for the CES,
Yeah.
we actually use the yeah, that's a good question. We actually did use the person sensor.
Okay.
Yeah.
Yeah, that's 1 to 3 meters. We also have a QR code reader that we adapted to person sensing, which is 1 to 6 meters. AI in a box. Very good question. Someone mentioned about Rabbit. Okay, so please keep in mind that Rabbit and AI in a box, they're two different devices for two completely different use cases. If you look at the hype video that the Rabbit folks put together, where they talk about, hey, you can initiate a query and you can have a response in 500 milliseconds. I think there's some popular videos going on right now which shows that in a lot of cases it's more like 20 seconds. So that's a device that's connected to the internet. And for it to do its thing, it utilizes smarts in the cloud to do what it does. Our device is completely disconnected from the internet. Okay. So some people are like, wow, how do you get that to work with a chat GPT like, user experience when it's disconnected from the internet? Well, that's the magic of what we do. And the reason why we did that is because we have a lot of customers with a lot of use cases who are really, really concerned about safety, privacy, security. Okay. They don't want something that's connected to the internet or the cloud. They don't want a central cloud-based system that's sucking up all that data and monetizing it or using it for who knows what, right? So we've gone a different route. And with our AI in a box, we can do some things that are similar to that, but completely private, safe, and secure. And our AI in a box, it's available on Crowd Supply. It's not really meant as a finished product. It's more of a hacking project device. That's where you can buy it. Um, but we use it more to show people and to show very large companies what we're capable of doing in terms of developing these type of user interfaces and these voice interfaces. All right, looks like there's a lot of other questions coming in here. Um, let's see. How close is the whole body detection model? Um, Pete, I think that's pretty close. Definitely Q1 of this year, right? Okay. Let's see what else. If IR light is added, the model is trained for black and white as well as color. I believe the answer to that is yes. John Craven on that one. Contact us through the website, and we'll get a specific answer to that question. I don't know if you know that off the top of your head, Pete.
I do, yeah, and so I was just muted because our dogs were barking a little bit. Yeah, so we have tested it and it does work quite well in near IR illumination. So if you add a near IR illuminating LED, then it does work, assuming that that's what you're looking to do, John. But yeah, please do contact us. We'd be happy to geek out about this.
Great. I think we're at the top of the hour here. I did drop some links in chat for everybody, and we will be sending out a follow-up email to everyone who registered with those resources and a link to the recording as well. So thanks, Pete and Terry. Thanks, everyone, for attending. I thought this was a great chat that we had today. So yeah, follow up with us if you want any more information.
Yeah, thanks, everybody. This was fun.
Thank you.